Hi everyone, and welcome to part 2 of the mathematics part 1. Mathematics paper 1, November 2017. In this section of the video, we're going to continue where we left off in part 1. We're going to deal with the sections involving functions, finances, as well as calculus. We're going to touch a bit of calculus. And please guys, before we even continue, please like, subscribe, and hit the notification bell to stay updated. So let's get into it without a waste of time. That is question 4. Given f of x equals minus ax squared plus bx plus 6, the gradient of the tangent to the graph of f at the point -1, 7/2 is 3. Show that a equals half and b equals 2. Now, we're given the gradient of the tangent to the parabola. Remember, in some of the applications of differentiation and calculus, finding the equation of the tangent to a curve is one of those applications. So in this section, in this part of the question, we are given that the gradient to the tangent to the parabola is 3. So that is very much important. So the question is show that a equals half and b equals 2. Let's get into it. That is question 4. Question 4.1. Now we're given that f of x was equal negative a x squared plus b x plus 6. Let me just go back to confirm. Yes, that's it. Negative ax squared plus bx plus 6. Now, remember from the applications of calculus, the first derivative of this function, the first derivative of the function gives you the gradient to the tangent of that function at that particular point, if given the point. So if we take the first derivative of this and equate it to 0, we are going to solve for whatever variable. So f x equals 0. Now let's derivate this using the rules. You know that this is 2, so it's going to be negative 2 ax 1 minus 2 minus 1, it's going to be 1. I'm not going to write it. Then plus b, the x goes away because the exponent is 1. 1 minus 1 gives you 0. X to the power 0 is 1. Then plus the derivative of a constant is 0. So I'm not going to write it. Equals 0. no, sorry about that. We were given that the gradient, the first derivative, the first derivative gives us the gradient to the gradient of the tangent to the curve, like I've said. So the gradient was 3, so the gradient was 3. And remember guys, we were given the coordinates. We were given the coordinates at that particular point. The coordinates are -1 and 7/2. We know the coordinates, so let's just substitute. These are the coordinates, -1 and 7/2. So substitute, it's going to be -2a, x is -1 plus b equals 3. Now it's going to be -2 times -1 is going to be 2a plus b equals 3. Now this is an equation. What do we do? Already we have, you know, the coefficient of b is 1, so let's just make b the subject of the formula. B equals 3 minus 2a. This is our first equation. Now again, let us use this point and substitute it here, because we are given the equation of the parabola, which was f of x equals -ax squared minus, was it minus? Yeah, it was plus bx plus 6. So substitute that point where y was 7/2 equals -a, x was -1 squared plus b -1 plus 6. Okay, let's simplify. 7/2 equals 1 squared is just 1. -1 squared is going to give you 1. It's -a plus, sorry, it's not going to be a plus here, pardon me. -1 times the b is going to give you minus b plus 6. So okay guys, let's just make this our equation 2. Remember what this is our equation 1. Now let's substitute equation 1 into equation 2. Or we can even, since the coefficient of b in this case is just -1, let's make b the subject of the formula, and make b the subject of the formula. It's going to be, take b this side and 7/2 the other side, to the other side. So b is going to be equal to -a minus 7/2 plus 6. You can work that out to confirm. So let's make this our equation 2. Now since they are equal, equation 1 and equation 2 both expresses b, so we can then equate them. Equation 1 equals equation 2. Now what we do is, remember equation 1 was 3 minus 2a. This was equation 1. It equals this equation that we've just written here, minus a minus 7 over 2 plus 6. Now let's simplify and solve for a. Let's take all the variables this side and all the constant the other side. So we're going to have negative 2a plus a, because the a is going to become positive, equals negative 7 over 2 plus 6 minus 3. Negative, sorry, let me just write it a bit. Negative 1, negative 1a equals, simplify this, it's going to give you negative half. Then divide both sides by negative 1a equals half. Now take this a and substitute it in one of your equations. Let's substitute it in equation 1 for simplicity. Substitute a in equation 1. B equals, what was equation 1? It was 3 minus 2a. So it is 3 minus 2a. Our a is half. Then this cancels. Then we're going to be left with 1 there. 3 minus 1 equals 2. We've answered the question. We have shown that a equals half and b equals 2. Now calculate the x-intercept of f, the x-intercept of this function. That was 4.2. Remember, let's just substitute the values of a and b. F of x equals, a was half x squared, b was 2, so it's plus 2x plus 6. Now to find the intercepts, to find the x-intercepts, we just, okay, yeah, let's start with the x-intercept. So with the x-intercept, make y equals 0. So therefore this is going to be negative half x squared plus 2x plus 6 equals 0. Multiply throughout by negative 2 to remove the fraction. Negative 2, so you're going to be left with x squared minus 4x, then minus 12 equals 0. Now we factorize. The factors of 12 are 1, 2, 3, 4, 6, and 12 itself. So which two of those can potentially give us the middle term, the second term? So it is 6 and 4 exactly. Sorry about that. Let's just use this space as our working space with x and x. we said the factors of 12 that can potentially give us this one was 2 and 6. Now cross multiply as before, as I've shown you. It's going to be 2x. X times 6 is 6x. Now what is going to happen if we add 2x and 6x? They're going to give us 8x. So it already tells us that the sign of 2x and 6x are not positive, neither are they both negative. So okay, by inspection, it means that the 6 has to carry a negative and this one has to carry a positive in order for the answer to give us negative 4x. Yes, so this is going to be negative, this is going to be positive. Here are our two factors. So x plus 2, x minus 6 equals 0, x equals negative 2, or x equals 6. Yes, these are our coordinates. Let's write them in coordinate form. It's negative 2, 0, and 6, 0. Now to find the y-intercept, let x be 0. Now from the equation, we can, where this x, we substitute 0. Y equals negative half. Where this x, substitute 0. Negative half squared minus 4, 0 plus 6. The two of these are going to give you 0. You're going to be left with 6. So let's write it in coordinate form. This is your y-intercept. It is 0 and 6. But if you remember, the question didn't ask us to calculate the y-intercept. I just calculated it because it's part of the intercept. Now let's move on to the next question. Calculate the coordinates of the turning point. Now guys, this okay, it was 4.3. There's many ways of determining the turning point. One of them is through converting the equation from standard form to vertex form through completing the square. I'm going to show you maybe at least 2 ways of determining the turning point. Now let's start with completing the square, because remember, if we complete the square and let the equation in vertex form, remember vertex form is this form: y equals a x minus p squared plus q. In this form, the turning point TP is PQ. But remember, we are not given the equation in vertex form, so let's convert it to vertex form. The equation was f of x equals negative half x squared plus 2x plus 6. Now we've got to the coefficient of this has to be 1, so which means we've got to divide throughout by half, by negative half. So take out a common factor of negative half. then x squared, we're going to remain with x squared, minus, if we take out a common factor of -2 of -half here, we're going to be left with -4x, then here -12. Okay, then -12 okay guys, what you do here is we're going to remember this is b. We have got to add this expression b over 2 squared. Now what is b? B is -4. So I'm going to do this. Okay, let me do it in a different color. And again, since you have added something on on the equation, you've got to subtract it. In that way, it is not going to have any effect on the original equation. Minus -4 over 2 squared, and remember minus 12. Sorry, pardon me for this. Let's go back to our original color, minus 12. Now f of x equals -half x squared minus 4x. I'm just trying to remember it. Then whatever was in the it is -4 over 2, -4 over 2 squared, divided by 4, -4 divided by 2 is -2, 2 squared is 4. So it is plus 4. This one is very important in this context. Then minus the other 4, then minus -12. I'm sure I didn't make a mistake. Let's just check to confirm. Yes. Now we've got to factorize this. If you look carefully inside the brackets, this bracket, this is a perfect square. This is a perfect square. I'm not even going to try to look for other factors there. It's going to be x minus 2 squared. Then -4 minus 12 gives you 16 minus 16. Now let's remove this bracket here, multiply throughout by -half, x minus 2 squared, then negative half times negative 16 gives you positive 8. Now we've got our equation in vertex form. Therefore, that means, remember, from this we can determine our turning point. Our turning point is going to be 2. It's going to be negative 2. The reason I'm saying that, no, it's going to be 2. Yes, it is 2, not negative 2. And 8. Then you've got your turning point. Now again, from this, f of x equals negative half x squared plus 2x plus 6. Now from this, if this is another way of determining the turning point. If we say the x value of the turning point equals negative b over 2a. Now let's substitute in the values. What is b? B is, it's going to be negative 2 over 2 times negative half. This cancels. We're going to be left with a negative 1 in the denominator. Then negative 2 divided by negative 1 gives you 2. This is the x coordinate of the turning point. Now take this and substitute it here. Let's substitute. Now y is going to be equal to negative half x is 2 squared plus 2 into 2 plus 6. Not going to waste time. This is going to give you 8. Now again, we've got our turning point, which is 2 and 8. This is the turning point. Okay guys, let's move on to the next question. The question says, sketch the graph of f and clearly indicate all intercepts with the axis and the turning points. Okay, let me just check if we're going to have enough space there. Okay, there's y intercept, there's our x-intercept, and the origin there. Okay, what were the coordinates, the x-intercepts? If I remember well, the x-intercepts were negative 2 and 6. So if we say it was somewhere here, it's negative 2 and 6 here. Okay, and the turning point was 2 and 8, so it's going to be somewhere here. So which means a graph is going to be, I'll just rectify that now. So it's going to be, this is 6, this is negative 2, and then the turning point is 2 and 8. Okay, and then let me just quickly go back to the equation. Clearly indicate all intercepts with the axis and turning points. What are we left with? We've got the x-intercepts, we've got the turning points. Now we're left with the y-intercepts. Remember, in the first question I solved for the y-intercept, even though it wasn't asked for in the question. So this is that's the reason I solved for the x-intercept. For the y-intercept, the y-intercept was 6, so it's going to be 6 here. Okay, then you can write, this is indicated that this is f of x. Now 4.5, use the graph to determine the values of x for which f of x is less than 0. In other words, for which y is less than 0. The values of x where y is less than 6, 6 is our y-intercept. 6 is our y-intercept. So in other words, it is all the real values this side, because okay, let me just use a different color. Where y is less than 6, it is here. Now on the graph where y is less than 6, the values of x where y is less than 6 are this, it's here. So the graph, remember, the graph continues up to infinity. Now it's going to be all the real values of x, so less than 0. So it is, yes, what I said is all the real values less than 0, it is this side. And again, what I'm going to do here is I'm going to draw in a dotted line, and again it is these values here, all the real values here. Now what is this point? What is the x value there? It is 4. The reason I said it is 4 is, okay, if we now look at the axis of symmetry, the axis of symmetry, it's going to be 2, where the x value, the x value at the turning point, it's going to be 2. It is 2. Now from here to here it's 2, meaning from here to here has to be 2. The distance from 0 to 2 and the distance from 2 to this point has to be equal. They're equal about the axis of symmetry. So that's the reason it is 4. I'm just going to undo all the mess. So remember, it was all the real values less than 0, and it is going to be all the real values. It's going to be all the real values greater than 4. So, which means, in other words, 4.5, it's going to be 0 is less than x, and x is less than 4. No, sorry, it is greater than 4, not less than 4. That is going to be your answer there. Okay, let me just look into that. No, it is going to be less than, it is 0 is less than, x is less than 4. Yes. Pardon me guys for that. Now let's continue to the next question. Sorry. Sketch the graph of g of x equals negative x minus 1 on the same set of x's as f. Clearly indicate all intercepts in the axis. Now 4.6, we given g of x equals negative x minus 1. Now let's determine the intercepts. Let's start with the x-intercepts. With the x-intercept, we let y equal to 0. Now y is going to be negative x minus 1, then simplify, take the 1 to the other side, then x is going to be equal to negative 1. Now in coordinate form, this is negative 1 and 0. Now the y-intercept, we let x equal 0. We let x equal 0, so y is going to be equal to negative 0 minus 1. Y is going to be equal to negative 1. In coordinate form, it's 0 and negative 1. Now let's go back to the graph. Since the instruction says we've got to draw it on the same axis as the graph of f, with a different color, of course. Let's choose the color to be B. The x-intercept was negative 1, say this here, and the y-intercept was negative 1. So it's going to be roughly something like that. Okay, let me just make a neat sketch. This is the graph of G. This is negative 1 here, and it's negative 1 here. Just place off this. Okay. Let's move over to the next question. Now use the graph to determine the values of x for which, I was reading this question, sorry about that. We are on this question. Write down the values of x for which f of x multiplied by g of x is less than or equal 0. Now guys, let's go back to the graph, and we don't have space. Okay, to create space, I'm just going to rub this off here. I'll write it on the next page. Now guys, what you do here, is we are going to create imaginary lines where both graphs cross the intercepts, the x-intercepts. We start with the x-intercept of the parabola and the x-intercept of the straight line there, the second intercept of the parabola. Now what we do is that let's look on this section of the graph less than -2. So G is positive, and F, the parabola, is negative, as you can see. Now let's look at this graph, or at this section of the graphs. If you can notice that the graph of F, the parabola, is positive in this section. Let me use a different color, say green. So it is positive in this section, and the graph of G is also positive. They are also positive because it is above the x-axis. Now let's look at this section between the x-intercept of the straight line and the second x-intercept of the parabola. Now this section, the parabola is positive throughout, it's positive, and the straight line is negative. Now what we're going to do is we are going to multiply both the signs. This is positive times negative, it's negative. Positive times positive, it's positive. Positive times negative, it is negative. Now remember the question, oh, I'm sorry about that, guys. I don't know what's wrong with me today. Now the question says write down the values of x for which f of x multiplied by g of x is less than or equal to 0, which means it is negative. Their product has to be negative. Their product is negative here and there. And on the x-intercept, it is 0, it is 0, it is 0. It's very important because we've got to also include it. So that means it is for x is less than or equal to this section, -2, and this section where -1 is less than or equal to x is less than or equal to 6. I hope you guys understand that, and I hope I was clear enough in explaining it. For 3 marks. Now let's move on to question 5. The diagram below shows the graph of g of x equals 2 over x plus p plus q, and f of x equals log base 3x. Now we are also given that y equals -1 is the horizontal asymptote, very important, of g. It's the horizontal asymptote of g. Now, without any waste of time, what the horizontal asymptote gives us, it gives us the value of q. So already we have the value of q. So in other words, g of x equals 2 over x plus p minus 1. Take note of that. And we also given that point P, which is 1, and 0 is the x-intercept of graph f, of this graph. It is the x-intercept. Now point A, which is t and 1, this point is a point of intersection of f and g. The vertical asymptote of g intersects the x-axis, this line. The vertical asymptote of g of the hyperbola intersects the x-axis at E, that point that we not even given, and the horizontal asymptote at D is also not given. Now OB equals BE, very important. OB equals BE, the distance between this and that are equal. So it means that you know that this is from the origin to point A, the distance there is 1 unit. Now since this distance equals BE, now from B to E is also going to be 1 unit. So it means that point E is 2 and 0. We already have point E from this statement, the statement that we are given. Write down the range of G. The range is the real values of Y for this graph. Now the range, remember, the range cannot be the asymptote, the horizontal asymptote. Since we are given the horizontal asymptote, it's Y equals -1. Now the range is all real values of Y, but Y cannot be equal to -1. That is a line, that is an imaginary line the graph approaches, but it will never cross. Now determine the equation of G. The equation of G. Okay, firstly, let's draw the graph. Okay, and we were given that the horizontal asymptote was Y equals -1. What we were not given is the vertical asymptote, but what we know is that it crosses the x-intercept at point E, and it also crosses the horizontal asymptote at point D. Okay, so let's now draw in our graphs. That is the first arm and the second arm. Okay, let's draw the graph of f with a different color. Of course, I'm going to choose the graph of f was the y-intercept of graph of f was at point B, which is 1, and sorry, let me just make that clear. That's point B, 1 and 0. Okay, we were also given this point. Let me use black color. This point A, which was t and 1. The first question was that we have to determine the range of the hyperbola. The range of the hyperbola, the range as y is an element of real numbers, but y cannot be the asymptote -1. Question 2, let me just go back. Determine the equation of G. Remember, G is the hyperbola. Hyperbola was G of x equals 2 over x plus q. It was x plus p, then plus q. But since we were given the horizontal asymptote, now that equals the value of q. Now we'll write that later. Sorry. We were also given that since I said the values of E were 2 and 0, the reason was that we were given that OB equals BE, and OB is 1, therefore BE also has to be 1. The length there has to be 1. Now the point at E has to be 2 and 0. Now therefore that means that this point, the point at D, is -1, it's 2 and -1, because that's where it crosses the y asymptote. The y, it is 2 and -1. Now this point is very important because it gives us the values of P and Q. We can just substitute in the equation. Now G of x equals 2 over x, it is the value of P is 2, it is x minus 2, then minus 1 was the value of Q. Now how did I get to -2 since the horizontal asymptote is 2? Now what you do is we had x plus p initially. Now you've got to equate this to 0. X plus p has to be equal to 0 at the vertical asymptote because it is undefined. Now we have the value of x. The value of x is -2. It was 2, then plus p equals 0. Solve for p, it will be equal to -2. That's why I substituted -2 there. I'm going to wrap this off to create some space. Okay, sorry about that. Let's move over to the next question. Calculate the value of t. Calculate the value of t. Now we can calculate this value in two different ways. We have remember T is the point of intersection of both the graphs at A. Now we can either use the equation of f of this graph or the equation of G, since we've got both equations. Now 5.3, that was 5.3. okay, I'm first going to start with the hyperbola, since it's here. G of x equals 2 over x minus 2 minus 1. Now we are given the y value. Remember, A is t and y and 1. We have the y value, we want the x value. We don't have the x coordinate there. So we're going to substitute in the value of y. 1 equals 2 over x minus 2 minus 1. Then simplify. Take 1 to the other side. It's going to be 2 equals 2 over x minus 2. Then you can cross multiply. You're going to have this is over 1. It's going to give you 2x minus 4 equals 2. Then take for the other side. You're going to be left with 2x equals 6 divided by 2. X will be equal to 3. That is the y coordinate at point A. Now let's use the graph of f. I'm going to work it out in this space here. Remember, the graph of f of x was log x, log base x 3. Now let's substitute the value of y, since we are given it is 1. So 1 equals log x 3. Now what do we do from here? We've got to convert to exponent form. Now remember how to convert. This is the base, this is the exponent, this is the number, this is the number, sorry. Now we're going to say base x to the exponent 1 equals 3. So x equals 3. Now that means the coordinate of A is 3 and 1. Let's move on. Write down the equation of the inverse of f inverse in the form of y. That was 5.4. Remember, f of x equals log base x 3. Now this equals y is the same as y equals log x 3. Now what you do with inverse functions, you just swap y for x and y, you just swap them. So that means we're going to have x equals log y 3, log base y 3. Then remember, they said we've got to make y the subject to formula, write it in terms of y. So to make y the subject to the formula, we've got to change to exponential form. So y is the base, so we're going to have y to the y to the exponent x, sorry, is this the, let me just go confirm. What was the equation of it was log 3, sorry, it is log 3 base, it is log base 3x. Pardon me for that. This log base 3x now, which means it's going to be log base 3y. Remember, we've got to make y the substitute of the formula, and I said we've got to convert to the exponent form, to the exponential form. So what we're going to do, I've been making a lot of mistakes today. It is, yes, this is x. You swap x and y, going to have log 3y. Now this is the base, like I've said, this is the exponent and this is the number. What you do is that you say the base, which is 3, to the exponent equals the number. Now let's start with y. That is the inverse of x equals 3 to the exponent x. Now let's move on to the next question. For which values of x will the inverse of x be less than 3? For which values? Now, okay, I'm going to show you on the graph, and I'm also going to solve for it. Now say if, okay, let's first draw the graph of the inverse of f with a different color. Of course, I'm going to choose a red. It's going to be, it's an exponential graph. So this is going to be the inverse. It's going to be 0 and 1. Okay, let me just wrap that off. It's going to be 1 here. Say the value where y equals 3, it's going to be somewhere here, 3. Now what is the x value where y equals 3? It is probably equal to 1. We can substitute it in the equation. Remember y, the graph of the exponential function was 3 to the exponent x. Now we want the value of x where y equals 3 to the power x. The exponent there is 1. Now, since the bases are equal, you know the rules of solving exponents. Since the bases are equal, you can drop them. Then x is going to be equal to 1. That means the value of x where y equals 3 is 1. Now they want the x values where y is less than 0. It means it's going to be down, it's going to be less than, it's going to go down this line. So the values of x are these. The values of x are going to be here because the graph continues in this fashion. I'm just going to remove the mess there. Okay, sorry about that. Yes, we were here. Now, like I've said, this is the equation of the inverse function. Now, since we were given the y value, it was 3 equals, okay, let me just express it in a appropriate manner. The question said, for which values of x will this graph be less than 3? So it means that this graph 3 of x be less than 3. Now remember, like I've showed you in the previous page, since the bases are equal, you can just drop them and remain with the exponent. So therefore for x is less than 1, I've showed you on the graph. I tried to explain on the graph. Let's move on to the next question. Determine the point of intersection of the graphs of f and the x and the axis of symmetry of G. Okay, what we're gonna do is we first gonna determine the axis of symmetry of G. The axis of symmetry of G. Let's go back to the graph. I'll show you where it's going to pass. The axis of symmetry of G, it's going to be through D. It's going to pass through D, and they are telling us that it's got to have a negative gradient. That has a negative gradient. It has got two axes of symmetry which pass through D. So there's one that is positive through D and one that is negative. So .5. So the axis of symmetry, like I've said, axis of symmetry will pass through point D, which we determined it was 2 and -1. Since we have the point and we also have the gradient, we can easily determine the equation in this form: mx plus c. We have the gradient y equals -x. What we don't have is c, but then we have a point which the graph pass through, which is D. So substitute this into the equation. It is -1 equals -2 plus c. Now -2, if we take it to the other side, it's going to be positive. So c is going to be equal to 1. Let's write it down. This is the equation of the axis of symmetry, then -1. It's -x plus 1. Now take note of that. Since okay guys, what we've got to determine from that equation, or pardon me for that, okay, let's determine the x-intercept. You know, at the x-intercept, the y value equals 0. 0 equals -x plus 1. Take x to the other side, so it's going to be positive. X equals +1. These are the x coordinate of the axis of symmetry, of the line of the axis of symmetry. It is 1, 0. Now at the graph, let's go back to the graph. Which other point Which other point has the coordinate 1, 0? It is B, which is the x-intercept of point F. Let's now go back to the equation. Determine the point of intersection of the graph of F and the axis of symmetry of G that has a negative gradient. The y-intercept of the graph of F is B. The y-intercept of the axis of the line of axis of symmetry is also 1 and 0. That means that is where they intersect each other, both graphs. I hope I made it clear. I'm not going to write that down. Okay, let's move on to the next question. Finance. Bali invested 10,000 for 3 years at an interest rate of R% per annum compounded monthly. At the end of this period, she received 12,147 and 72 cents. Calculate R correct to 1 decimal place. Calculate R correct to 1 decimal place. Now we are on question 6. This is 6.1. What are we given? We are given that A equals 100 and it equals 12,400 and okay, let me just go back to confirm. 12,147. Oh, sorry about that, guys. 12,147 and 72 cents. And it's 72. Yes. P equals 10,000. We don't know I, which equals R%. We don't know it. And we know N, the number of payments. It is paid in 4. It was paid in 3 years. 3 years. And okay, I'm just going to go back to the question. I'll come back to that. Let's read the question again. Mbali invested 10,000 for 3 years at an interest rate of R% per annum compounded monthly. Now, what that is saying is that effectively it is effectively compounded monthly, so it is paid in monthly installments. I mean, it is going to gain interest every month. So it means it's going to be 3 years times 12 months. That is the value of N. The value of N times 12 equals 36. We have to calculate the percentage. Now A equals P1 plus I, and let's substitute in the values. A equals 1, 12,014, 7.72. P was 10,000 into 1 plus I. Very important, guys. Since it's compounded monthly, we're going to divide I by 12, just like we multiplied 3 by 12, which gave us 36. Now we're going to divide both sides by 10. Going to have 12 147.72 divided by 10,000 and equals 1 plus I over 12 all raised to the power of 36. Now we've got to take the 36th root, both sides, apply it. 36. Now we're going to be left, let's write this here, 1 plus I over 12 is going to equal to 147.72 over 10,000. Remember, it is the 36th root. Take 1 the other side and at the same time multiply by 12. It's going to, I is going to give you 147.72 over 10,000, 36th root, minus 1, all of this divided by, it is all of this multiplied by 12. I'm going to create some space here, times 12. Let's punch this into a calculator. Our I is going to be equal to 12. Okay, let me do this. The 36th root of 1 to 147.72 divided by, okay, I just realized, but then I'll fix it, divided by 10,000. Okay, let me start over. It is into brackets the square, the 36th root of 12147.72 divided by 10,000, then minus 1, all of that multiplied by 12, that is 0.65. remember they set to 1 decimal place, so I'm just going to take it the 0.065. So I equals 0.065. Then in percentage form, it's going to be equal to, multiply by 100, 6.5%. Okay, let's move on to the next question. The next question says Pete takes a loan from a bank. Guys, immediately the question says someone takes a loan, then you know that you are dealing with future value annuities. It is something that you are taking now and then you have got to pay it back depending on the arrangement with your bank, with the bank. So Pete takes a loan from a bank to buy a car for 235,000. He agrees to repay the loan over a period of 54 months. The first installment will be paid 1 month after the loan is granted. Very important with present and future value annuities. The first payment is made at the end of the month. Say I take a loan today. say today it's 1st of February, I've got to pay back, I've got to start pay the first installment at the end of the month, 28th of February. Now it continues to say the bank charges interest at 11% per annum compounded monthly. Calculate BIT's monthly installment. Okay, this is 6.2.1. Like I said, it's present value annuities. That is your equation. 1 minus 1 plus I negative n all over I. Now what we have the loan, which is the present value annuity. We have I, the interest rate, we have n, we don't have x. We've got to calculate the monthly installment. Now guys, let's substitute in the values we were given. The loan was worth 235,000 equals x into 1 minus 1 plus, it was compounded, the interest rate was 11%, so it's going to be 0.11 compounded monthly. Very important. Paid in 54 monthly installment, all divided by the interest rate over 12. Okay, let's remember everything here because we're going to need it on the next page. Now make x the subject of the formula. X, okay, let me just rewrite that whole expression we had. It was 235,000 equals x into 1 minus 1 plus 0.11 over 12 to the exponent negative 54 over the interest rate. Now we've got to make this the subject of the formula. We've got to make that the subject of the formula. X, you've got to multiply both sides by this, so which means we're going to multiply by 0.11 over 12. Okay, before I even make x the subject of the formula, we're going to have 235 times 0.11, then all of this divided by 12. Okay, now which means we are going to cancel this out. We're going to be left with x and whatever is inside this bracket. Now while we are still on it, we are also going to divide by this, the whole of this, which means it's going to go to the denominator, so it's going to be times 1 minus 1 plus 0.11 over 12 to the exponent negative 54. That is going to be equal to x. Therefore x equals, let's punch that in, it was 235,000 multiplied by 0.11 all over 12 into 1 minus 1 plus 0.11 over 12 to the raised to negative 54 sorry, negative 54. That is 5,536.95. It's 5,536.95. That is the monthly installment that PIT is going to pay every month to the bank. Now calculate the total amount of interest that PIT will pay during the first year of the repayment of the loan. During the first year, what it means is after 12 payments, a year is made up of 12 months. So it means PIT is going to pay 12 monthly installments. Now we want to determine the amount of interest that PIT will pay during the first that PIT will have paid in the first 12 months. What you do is that given the monthly installments, okay, given the monthly installments, it is 6.2.2. This is the monthly installment. We are going to multiply that by 12. Those are going to be PIT's payments. Now from that, we are going to determine how much interest PIT paid. Now it's going to be 5,536.95 multiplied by 12. Now it's going to be 5,536.95 times 12. This gives us 66,443.4 equals, okay, let me write it here, equals 66,400 it is 66,400 and let me just go back to confirm. Yes, 443.4. 43.4. Now, this is the amount of money PIT is going to pay in 1 year. Now, we want to calculate the balance that is going to remain after PIT has paid 12 installments, monthly installments. We want to calculate, remember, the interest is charged on the balance that is left, that is due. So, okay, from there's two ways of calculating the balance. I'm going to show you the first way. Now, the balance equals, okay, with the balance, we've got to determine the number of payments left. Now, N is going to be the total number of payments, which is 54, minus 12 payments. It gives us 42. Now, what we're going to do is that use the formula, which the present value annuity formula. We already know X, the monthly installment, is 5,536.95 into 1 plus, sorry, it is minus for the value, for the present value. 1 plus the I was given at 0.11 over 12. Now the n is no longer 54, it is negative 42 all over 0.11 over 12. Let's punch that in. It is 5,536.95 into 1 minus 1 plus 0.11 over 12 raised to negative 42 all over 0.11 divided by 12. Now it equals 192,296.1. Let's round it off to at least 4 decimal places, because this is a metal calculation. 1950, 1951. I'll remember that, I think. Then it's going to be equal to 192,296.1951. This is the balance that is due after 12 payments. Now from this balance, we are going to we are not interested in this balance. We are not interested in this balance, but what is within that 12 monthly installment. Therefore, we are going to subtract this from the loan amount that we know. So amount paid off. So the amount paid off in 12 months, the one that we are interested in is going to be equal to the loan amount 235,000 minus the balance after 12%, after 12 payment, which is 192,295.1951 equals, let's punch that in, 235,000 minus 192,296.1951. That is 42,700 and 42,703 point 2,703.8049. Again, I'm not going to round this off to 2 decimal places, because we are not yet done. This is a metal calculation. Now what is going to happen is that we are going to take, this is the number of payments excluding interest. This is the number of payments that John would have paid, that Pete would have paid, excluding interest. Now remember this, where is that? This is the amount including interest. Now how do you go about determining the interest? You will take this and subtract the amount without interest. This is 666,400 it is. Okay, let me just do this. Okay, it is 66,443.4. So therefore interest equals 66,443.4 minus this one. Okay, let me make sure this space, we have enough space. 66,443.4 minus 42,703.8049. Let me confirm if I haven't made a mistake. 66,443.4. Okay, let's punch that in. 66,443.4 minus 42,703.8049. That is 23,735.60. That is 23,739.60. This is the total amount of interest that John would have paid in the first 12 payment. That is a lot of money. Taking a loan is a bad idea, because John Pete isn't yet done paying off the loan, but then after 12 payment, this is the amount of interest that he would have paid. Imagine the amount of interest that he would have paid after the total amount of payment to seal off the loan. Okay, I'm now going to continue to question 7. Question 7, given f of x equals 2x squared minus x. Guys, I'm a little bit tired. It's been more than an hour already. Determine f prime x from first principles. That's where you've got to score most of your answers, because you just apply the first principle and you don't think of anything. You don't waste a lot of energy there. So the first principle from the formula sheet, it's given f of f prime x equals the limit when h approaches 0. This is very important. F of x plus h minus f of x all over h. Now remember f of x was 2x squared minus x. Now it means where there is x, we are going to substitute f. We're going to substitute x plus h. So it's going to be equal to limit h when h approaches 0. Guys, this is very important. The limit when h approaches 0, it's very important. Don't drop it. So it's going to be 2x plus h squared minus, remember it was, let me just write it there, it was 2x squared minus x. We are not yet done with the x plus h, minus x plus h, then minus f of x, which is 2x squared minus x minus x. Yo, we don't have space, guys, all over h. I'm going to move this a little bit to the left, so it's going to be equal to the limit when h approaches 0. So we're going to remove the brackets there. It's going to be 2 into x squared plus 2xh plus h squared, then minus x minus h minus 2x squared minus x all over h. It's equal to the limit when h approaches 0. We've got to, you can see that x cancels x. What have I done there? Yo, guys, because of space, okay, I'm going to repeat this step, and then I'm going to move this a little bit to the left, all of it. This is some of the mistakes that happen in the exam room, that you do, guys, in the exam room. So be careful. So it's equal to the limit when h approaches 0. It is, we are going to substitute x plus h. It is 2 into x. Remember, this is h. 2 into x plus h. Oh, sorry. Yes, squared minus x plus h, then minus f of x into brackets. There's a minus sign. Remember, before I didn't put in the brackets, so there's a minus sign. Be careful. Minus 2x squared minus x, all this over h. So it equals to the limit when h approaches 0. Now remove the brackets. 2 into x squared plus 2xh plus h squared, then minus x minus h by removing this bracket, then minus, remove this bracket, 2x squared plus x over h. This cancels already. Then we are removing this bracket, equal to limit when h approaches 0 to, okay, let me just write this a little bit, 2x squared plus 4xh plus 2h squared, now minus h minus 2x squared all over h. All over h. We are going to cancel this. This cancels out. Then we are left with all the terms with h. We are going to take out a common factor of h equals lim h approaches 0. Take out a common factor of h. We are going to be left with 4x plus 2h, then minus 1 all over h. Then h cancels. We are left with lim when h approaches 0. Now we are going to be left with 4x plus 2h minus 1. Now, since we don't have h as a denominator, now it is valid that when h approaches 0, remember, when h was still there as a denominator, when h approaches 0, then the whole of this expression was going to be undefined. Now, since we don't have h as a denominator, now when h approaches 0, this is going to be 2 times h, which is 0. It's going to be 0. We are now going to be left with 4x minus 1. Now, this is where you drop the limit h approaches 0 because you have applied it. It's going to be 4x minus 1. Then you get your full marks there. Sorry, let me just... Now, 7.2, determine 7.1 dx of whatever is inside that bracket. Okay. That is 7.2.1 dx x plus 1 3x minus 7. Now guys, since you don't know the product rule, you cannot differentiate when it is in that form. You've got to simplify the inside of the bracket first. So it's going to be dx x times 3x is going to be 3x squared, x times negative 7 minus 7x, 1 times 3x plus 3x, x times negative 7 minus 7 dx 3x squared negative 7x plus 3x is negative 4x minus 7. It is now that you can apply the rules of differentiation to differentiate. Now, therefore, it equals to 2 times 3 is 6x, 2 minus 1 is 1. I'm not going to write it. Then minus the middle one, 1. The exponent to 1 times 4, it's 4. Then we're left with 1. 1 minus 1 is 0. Then x to the exponent 0 is 0. Then the derivative of a constant is 0. I'm not going to write it. Then that's it. You have your full marks. Now 7.2.2. It says dy over dx if y equals root x cubed minus 5 over x plus half pi. Now this is where you score a lot of marks, guys. Dy over dx, what it means is differentiate y with respect to x. Okay, where y equals root x cubed, the square root of x cubed, plus 5 over x plus half pi. Now guys, what you've got to do is we have to apply the rules. We have to convert all the sets and all the fractions to exponent form, to exponential form. We have got a set here, we've got a fraction there. So let's now convert them. Y is going to be equal to, since you know this is a square root, so there's a 2 there, even though it's not written, then x is going to be 3 over 2, the exponent x to the power 3 over 2, plus, remember the rules of exponents, to convert this to exponential form. You're going to have 5x negative 1, then plus half pi, that is a constant. Now it's then that we can take the derivative. Okay, I'm going to go to the next page. Now dy over dx is going to be equal to okay, let me just write it here so that we have it on this page. Y was equal to x raised to 3 over 2, then plus 5x minus 1 plus half pi. Now dy over dx is now going to be equal to, use the rules of differentiation. It's going to be equal to 3x over 2, 3 over 2 minus 1 plus 5. Okay, it's not going to be equal to 5 because negative 1 times positive 5 is going to give you minus 5 to the exponent negative 1 minus 1. Then the whole of this is a constant. It's going to be 0 plus 0. Now we're going to have 3 over 2, 3 to the x to the exponent 3 over 2 minus 1 gives you half, then minus 5x to the power negative 2. You're going to get marks if you leave it like that. If you like, you can simplify it, then you're going to be left, you're going to have 3x, it's equal to 3 root x over 2 minus 5 over x squared. But you're going to get a full mark if you leave it like that. As I think we are done, I'm going to leave it here, then I'm going to carry on in the next part of this session on the 2017 mathematics paper 1. Okay, thank you guys for your time. We'll meet next time. Thank you.